right. Kirchhoff's rules, we use them to solve complex circuits, and there are two of those rules. The first one is the junction rule, which tells you about the current. The current that comes into the junction equals the current that comes out of the junction. Or, imagine this, if I have two resistors connected in parallel, and my current is flowing like that, then these two currents are coming in and one total current is coming out. And these two, and the sum of these two currents equals this total. So whether we're talking about this that came in equals the two that comes out, or vice versa. So that's the first one, the junction rule. So the junction rule talks about the current. The loop rule, or the loopy rule, talks about potential difference, and it talks about it in terms of rise and fall. You know that inside the battery, if we look here, we have plus and minus. We're going towards the positive inside the battery. So we're going from lower potential to higher potential. That's why it's called the rise. And then outside, through the circuit, you know, electrons are going to go towards higher potential, but since we're talking conventional current, that's positive charges. Positive charges are moving towards lower potential. So therefore, we have, if I choose the direction of the loop to be clockwise, this 18 volts will be my rise. Everything outside will be the fall. And here I have the battery, and look, I'm going from positive to negative, which is the fall. So 12 is part of my fall. And then I have 3 resistors that also use up voltage, and that's also the fall of potential difference. So the fall of the potential. Now the rise is 18 volts. The fall should also be 18, and it consists of the battery, which is 12 right here. So that is your battery, and then the rest, the 6, I could present as R1 plus R2 plus R3, because there are 3 resistors in my circuit, times I total. That will be my 6. Okay, here's an example. Let's say I have 2 resistors and 2 batteries, and I need to find the total current. So the first thing I need to figure out is the direction of my current. Again, I can choose it. The worst thing that can happen if I choose it incorrectly, my current will be negative. This is kind of common sense here. This right here is a higher voltage battery. So I will choose this direction to be the direction of my current. So here, this will be part of the fall. Here we have fall. Here we have fall. And this is my rise. Right? So then, this is my rise, this is my fall. Again, that comes from the battery right here. So then 1 is the potential difference on that guy and that guy. Since they are in series, I can say that their total resistance is 0.30, because that's 0.015 plus 0.015, and that's my R total times I total. That's exactly what I'm looking for. So then I'm going to say 1 over 0.030 is 33 amps. So that's the easy one. Now here's your homework. So here we will have 2 loops. That's my first loop. Loop 1, and that's my loop 2. Now remember, when we started doing it in class, I suggested doing it this way. And I looked like at the total one, and then at this one separately. That was not right. So here we have the loop 1, that's the right loop, and the loop 2, that's this one. like if the way I suggested it, this would have worked if this didn't have a battery inside here. All right, so anyway, so we're going to look at loop 1 and loop 2. Loop 1, figuring out the direction. Again, it's up to you to choose the direction. And then it's kind of common sense here. Since this guy is 15 volts, it's natural to say that that is my rise. Then my fall will be, here's 1, here's 2, here's 3. There are my 3 falls. This right here is 10 times I1, and this will be 10 times I2, because obviously you know that there is a loop here. I mean, not the loop, the junction. So the current will go that way, but it will also come this way. Or, I'm not quite sure about this one anyway. So let's see. This is the rise, that's the fall, and they all equal, so I can say 15 equals 10I1 plus 10I2 plus 2, or I can even say 13 equals 10I1 plus 10I2, and that's it. All right, then that's my loop 1, my loop 2. And Evan was right, and I'd like to point it out, because remember, I decided to go the same way. I suggested this direction of the loop, but it wouldn't work, because think, if this is my 2, and then this is one of my falls, and this right here, the 10, is my other fall, then and this is like my 1, that's my 2, that's my 3 falls. If this right here is 2 and it equals 5 times something plus 10 something, obviously that something and that something is wrong because it's negative and negative. So I was wrong choosing that direction. So Evan was right. So the correct direction of the loop, of the current in this loop, is actually that away. In this case, this right here is my rise, which is 10. And then if I rise here, I fall on this guy, which gives me 5I3. I also fall on that guy, which gives me 10 times I2. And we also fall on the 2-volt battery, which is right here, 2 volts. Now, the question of the problem is the delta V on that guy. So in order to figure out the potential drop on that guy, we need to find the current through it. All right. Brace yourself, because there's going to be a lot of algebra here. But other than that, we're good as far as physics goes. All right, so since our currents loop in onto the 10 ohm, because remember, here we have one current coming through here and going this way, the other current flowing that way. So this battery is a fall for both. So then the junction here, these two currents that came in, I dubbed this as I3 and this as I1, they should equal I2. And I'm saying as much. And then this was from our first loop. This came from loop 1. This came from our loop 2. And what I'm going to do, I'm going to subtract one equation from the other. Doing this, I'm losing 2, and I'm also losing 10I2 and 10I2, which brings me to 5, which is 15 minus 10, 10I1 minus 5I3. Again, I subtracted one equation from the other. Now, oops. My next step, I'm going to take this equation and multiply by 10, and it will become this. So all I did, I multiplied everything by 10. And then from this equation right here, I had 10 equals 5i3 plus 10i2 plus 2. I put 2 over here and end up with 8 equal 5i3 plus 10i2. And instead of 10i2, I'm going to write, instead of 10i2, I'm going to write that. So I have 8 that came from 10 minus 2. 5i3 came from here. So 5i3. Instead of 10i2 again, I'm writing 10i1 plus 10i3. That brings me to 8 equals 10i1 plus 15i3. Then that equation right here, I got from subtracting one equation from the other. So there you go. And then again, I will subtract this equation from that. And I will end up with 3 equals. So I lose these two guys. Bam, bam. My favorite thing to do. And that is minus minus becomes a plus. So it's 3 equals 20i3, which gives us I3 equals 0.15 amps. And since we're figuring out the potential difference, the resistance is 5, so therefore it's 5 times 0.15 is 0.75 volts. And that's it.